In this video, I'm using Claude Code to set up a new Python project for Blender. This will be the 6th implementation in my TextSphere demo series, joining the Godot, 3JS, D3, WebGL, and CSS versions. I'm starting by creating a new GitHub repository called blender-samless-sphere under the Software Writer organization. On the left, I have Claude Code ready to help with the project setup. The repository is created on GitHub. Now I'm initializing it locally with git init and creating the initial README file. Claude Code is helping me set up the project structure. Running the standard git commands, git init, touch readme, git add, and making the first commit. This establishes the basic repository structure before adding the Python scripts. I ran into a permission error when pushing. I was using the wrong GitHub account. I need to update the remote URL to use the correct software writer organization credentials. After fixing the Git remote configuration, I successfully pushed the initial commit. Now I'm asking Claude to help create the project documentation. Claude is fetching my other TextSphere repositories for context, the CSS, 3JS, and Godot implementations. This helps it understand the visual style and architecture I'm going for. Claude is creating the PRD document outlining the project goals. Create a Blender implementation that matches the existing web demos, and generate high-quality video output for the comparison video. Now Claude is creating the architecture and design documents. I'm asking it to also create a README with an overview and links to all the documentation files. The architecture document shows the entry point will be run blender.sh, which will invoke the Python scripts. Claude is working through the documentation systematically. Claude wrote 244 lines to the design document covering visual design and color palette. The design uses a rainbow spectrum matching the CSS and 3JS illuminations for consistency. Now it's creating the planning document with implementation phases and task breakdown. This will help track progress as I build out the Blender scripts. The status document shows Phase 1 project setup is in progress at 15% complete. Claude is tracking overall progress across all implementation phases. Claude found 36 files in the project and is now creating a comprehensive README with links to all the documentation. This gives anyone looking at the repo a clear starting point. Running git diff shows the README changes. The git log confirms we're building on the initial commit. Now Claude is ready to commit all the documentation. Claude is pushing the commits to GitHub. I'm confirming the git push command. This will upload all the documentation files to the remote repository. I noticed that the README markdown is not previewing correctly, so we will have to fix that. The initial project setup is pushed to GitHub with all the documentation in place, the README links to all 6 TextSphere implementations. Now let's fix that markdown formatting issue. Now I need to fix the markdown files. The README and other documentation aren't rendering properly on GitHub because Claude used special Unicode characters that GitHub doesn't display correctly. I'm asking Claude to check and repair the markdown documents. The issue is that Claude generated documentation with fancy Unicode symbols like tree characters, check marks, and arrows that look great in the terminal but break on GitHub. The Markdown checker found several issues. There are Unicode control characters, tree symbols, and other special characters that need to be converted to plain ASCII for GitHub compatibility. Claude is now reading through the documentation files and fixing the problematic characters. It's starting with the README and then moving on to the architecture documentation. Here Claude is examining the raw bytes of the README file to understand exactly what Unicode characters are causing the problems. This hex dump shows the non-ASCII characters that need to be replaced. Claude is converting the tree symbols in the architecture documentation to ASCII equivalents. The fancy box drawing characters are being replaced with simple dashes and pipes that render correctly everywhere. The status documentation also has progress bar characters that need fixing. Claude is systematically going through each markdown file and replacing the Unicode symbols with ASCII alternatives. The README validation passed. Now Claude is checking and fixing the remaining documentation files, including the design and planning documents. Claude is reading through the design documentation, which has over 200 lines. Each file with tree structures or box drawing characters needs to be converted to plain ASCII. Here you can see Claude fixing one of the pipeline diagrams. The arrows and flow indicators are being converted from Unicode box drawing characters to simple ASCII like dashes, pipes, and greater than signs. With all the fixes complete, Claude is now committing the changes. 5 documentation files were modified with 145 lines changed to ensure proper GitHub rendering. The commit is done and Claude is pushing the fixed documentation to GitHub. Now the README and all the other markdown files will display correctly in the GitHub repository. When I try to test the scripts, Claude discovers they haven't been implemented yet. So I ask Claude to implement them. Claude creates 5 Python modules for the Blender text sphere configuration, scene setup, animation, rendering, and an orchestrator. With the scripts implemented, Claude runs Blender to test the rendering pipeline. This takes several minutes as Blender renders each frame of the animation. The first render is complete. The animation shows rainbow letters orbiting the sphere, but the sphere is translucent when it should be opaque. Claude will fix the material properties. The sphere is now opaque, but the animation is too fast. I want the letters to orbit slowly and stately, completing a full 360-degree loop so it loops smoothly. After viewing the animation, I noticed 2 issues. The orbit direction is counterclockwise when it should be clockwise, and the animation jumps at the loop point. Claude will fix the rotation direction and render the full 30-second seamless loop. Now we need to capture a screenshot of the final animation to add to the project README. I'm using the Chrome MCP tool to take a screenshot of the rendered video. The screenshot is saved. The README is updated with a cache busting link, and now we're pushing everything to GitHub. The Blender Sphere project is complete and live on GitHub. In this video, we built a Python scripted Blender project that renders 3D rainbow text orbiting a translucent sphere. We went through several iterations to fix the orbit direction, animation speed, and seamless looping. The final result is a 60 FPS video that matches the visual style of our web UI demos. If you found this helpful, please like and subscribe, hit the bell for notifications, and leave a comment if you have questions. See you in the next one. Bye.